I'm Zach Shriver.
I'm John Hoaglund.
And I'm Donald York.
And this is the Frisby Stereoacuity Test. First, we'll explain the Frisby Stereotest. What you have is multiple test plates. And on the test plate, there's one pattern printed on the front for 3 out of the quadrants, and half of the pattern for the 4th quadrant is printed on the front, and half is on the back. This creates a disparity. In this test, the observer is asked to detect that disparity in one of the quadrants between the pattern that's printed on the front and pattern printed on the back. This method uses forced choice, so the observer is always required to pick one of the 4 quadrants which they believe contains that disparity. This is a test of depth perception. Because of the forced choice methodology of this test, there's a guessing rate of 25% because one of the 4 quadrants with the disparity can be guessed at that rate. To determine the threshold, you will look at the percentage obtained that is halfway between the guessing rate and perfect observation, which is 100%. So for this test, our threshold will be at 62.5%, which is halfway between the guessing rate of 25% and perfect observation at 100%.
This stereoacuity test is performed at 9 different test distances, ranging from 25 centimeters all the way to 4 meters. At each test distance, the patient is forced to do 10 trials apiece for accuracy.
So at each test distance, we have a choice between 3 different plates, 6 millimeters, 3 millimeters, and 1.5 millimeters. And each time we do a different trial, we rotate the plate so it has a better random chance for the patient guessing. And now for some do's and don'ts. Do keep the top edge of the plate separate from the background of the box. Do keep the plate square in the observer's line of vision.
Do not hold the plate against the background. This enables monocular cues.
Do check for understanding it. The patient understands the test and make sure they choose a quadrant for every trial.
Do not allow the patient to choose no quadrants or multiple quadrants. Donald. Do not throw the plate like a frisbee.
And now for a demonstration of the test. Now that we have collected all the data through 10 trials at each of the 9 test distances, we are ready to convert the distances to stereoacuity measurements in seconds of arc. To do this, we will use the equation shown here, and we will multiply the constant by the interpupillary distance times the average plate thickness, which in this case is 0.15 centimeters, and we'll divide that by 1.49 times the viewing distance squared. This allows us to determine the percentage of recognition at several levels of disparity based on our test distances. We have also included a chart providing some shortcut estimations from the Frisby test instructions. Now that we have converted our distances to seconds of arc to determine stereoacuity, we'll now plot the function. On the x-axis, we will have the disparity in arc seconds, and on the y-axis, we will have the percent correctly identified as far as how many times the target was correctly identified by the observer out of the 10 trials. Then we will find the point on our function that corresponds to 62.5%, and this value is our determined threshold stereoacuity.
Thanks for watching our demonstration of the Frisby Stereoacuity Test.
They know that's where I'm at. Plus I got one. I keep my shades on in the hot sun.
It's like, for some reason it's not auto. There he goes.
Okay.
Yeah.
It's 1.5 millimeters. I'm not reading here.
they know that's where I'm at. Plus I got one. I keep my shades on and the hot sun.
Allow the patient. Really?
Okay.
It's do not allow the patient to choose multiple.
Thanks for watching our demonstration of the Frisby Stereoacuity Test.
Fresh up out the airport. I'm like Tom Cruise off a Top Gun. Why? Cause they know that's where I'm at. Plus I got one. I keep my shades on in the hot